Hello folks, welcome back to our channel. Today we are going to learn about error bars and their implementation in Matplotlib. In first half of this video we are going to learn only theory part about error bars. In the next half of this video we are going to see introduction to Pyplot's error bar function, its parameters and example implementation. So without doing any late, let's see an introduction to error bars. In the realm of data visualization, precision is paramount. Every plot, chart, or graph aims to convey information accurately, allowing viewer to glean insights with confidence. Amidst this pursuit of precision, error bars emerge as indispensable tools, serving as silent yet crucial guardians of data integrity. In the domain of Matplotlib, a popular Python library for creating visualizations, the utilization of error bars adds a layer of depth and clarity to plotted data, enriching the narrative it seeks to portray. The importance of error bars in visualization. When we delve into the world of data visualization, we often encounter captivating graphs, charts, and diagrams that aim to convey information in a clear and concise manner. Yet, behind these visually appealing representations lies a crucial aspect that often goes unnoticed, but holds immense significance. Error bars. Error bars are the unsung heroes of data visualization, providing valuable insights into the reliability and precision of the data being presented. In simple terms, error bars represent the uncertainty or variability associated with each data point, offering a visual representation of the range of possible values. Imagine you are conducting an experiment to measure the effect of a new drug on patients' blood pressure. You collect data from a sample group and plot the average blood pressure before and after administering the drug. Without error bars, your graph might suggest a significant decrease in blood pressure post-treatment. However, incorporating error bars reveals the variability within the data, indicating the degree of confidence in your findings. Error bars come in various forms, each serving a unique purpose in conveying uncertainty. Standard error bars depict the standard deviation or standard error of the data points, showcasing the spread of values around the mean. Confidence intervals provide a range within which the true population parameter is likely to fall. Meanwhile, uncertainty bars represent asymmetric error ranges, acknowledging potential discrepancies in different directions. So, why are error bars so crucial in visualization? Firstly, they promote transparency and honesty in data representation. By including error bars, researchers acknowledge the inherent uncertainty in their measurements, fostering trust and credibility in their findings. Moreover, error bars aid in decision-making by helping viewer assess the reliability of the data and the robustness of any conclusions drawn from it. Furthermore, error bars facilitate comparisons between different datasets. When comparing two sets of data, such as experimental and control groups, error bars allow us to determine whether any observed differences are statistically significant or merely the result of random variation. Without error bars, misleading interpretations and erroneous conclusions may arise, leading to flawed decisions. In addition to their analytical utility, error bars enhance the interpretability of visualizations for a diverse audience. Whether communicating scientific research to fellow experts or presenting data to the general public, error bars provide a universal language for conveying uncertainty. Their presence fosters informed discussions and encourages critical thinking, empowering individuals to question assumptions and scrutinize conclusions. In conclusion, error bars play a pivotal role in data visualization, serving as essential tools for conveying uncertainty and promoting robust analysis. By incorporating error bars into visualizations, researchers and communicators alike can enhance the accuracy, transparency, and interpretability of their findings. As we navigate the vast landscape of data-driven insights, let us not overlook the importance of error bars in illuminating the path towards knowledge and understanding. The imperative of error bars, a critical component in data visualization. In the realm of data visualization, where insights are distilled into visual representations, the inclusion of error bars stands as an imperative practice. These unassuming lines or bars encapsulate vital information about the reliability and uncertainty inherent in the data being presented. Their omission could lead to misinterpretation, erroneous conclusions, and ultimately, flawed decision-making. Error bars serve as guardians of truth, offering a glimpse into the variability and precision of data points. Picture a scenario where researchers are comparing the effectiveness of different marketing strategies based on sales data. Without error bars, a seemingly significant difference in sales figures might be misconstrued as conclusive evidence of one strategy's superiority. However, integrating error bars reveals the extent of uncertainty surrounding each data point, prompting a more cautious and nuanced interpretation. One of the primary roles of error bars is to convey the dispersion of data around a central value, typically the mean or median. Standard error bars, for instance, represent the standard deviation or standard error of the data, providing insights into the spread of values. Confidence intervals offer a range within which the true population parameter is likely to lie, guiding viewer in assessing the reliability of the findings. Moreover, error bars facilitate comparisons between datasets, enabling viewer to discern meaningful differences from random variation. In scientific research, for instance, error bars aid in determining the statistical significance of experimental results. They help distinguish between genuine effects and mere noise, thereby guiding researchers towards robust conclusions and informed decisions. Beyond their analytical utility, error bars contribute to the clarity and transparency of visualizations. Whether communicating complex scientific findings or business metrics to a diverse audience, error bars serve as a universal language for conveying uncertainty. Their presence fosters trust and credibility, as viewers appreciate the honesty and rigor in data representation. In conclusion, error bars are not mere adornments in data visualizations. They are indispensable tools for conveying uncertainty and promoting sound decision-making. Their inclusion is not a matter of preference but a matter of necessity in the pursuit of truth and accuracy. As we navigate the vast landscape of data-driven insights, let us heed the imperative of error bars and ensure that our visualizations reflect not just what we know, but also what we don't know. Exploring the diverse applications of error bars in data analysis. Error bars, those unassuming lines or bars that adorn our graphs and charts, are not merely decorative elements, they serve as powerful tools with a multitude of applications in data analysis. From scientific research to business analytics, error bars play a crucial role in illuminating the uncertainty and variability inherent in data, thereby enhancing the robustness and reliability of our conclusions. One of the primary applications of error bars lies in providing insights into the precision and reliability of experimental results. In scientific research, where accurate measurements are paramount, error bars offer a visual representation of the uncertainty associated with each data point. Researchers can assess the consistency and reproducibility of their findings by examining the magnitude and direction of error bars, thereby ensuring the integrity of their experiments. Moreover, error bars facilitate comparisons between different groups or conditions. In experimental studies, researchers often seek to determine whether observed differences are statistically significant or merely the result of chance variation. By incorporating error bars into their visualizations, researchers can discern meaningful differences from random fluctuations, guiding them towards more informed interpretations and conclusions. In addition to their role in scientific research, error bars find applications in quality control and process improvement. In manufacturing and industrial settings, where consistency and reliability are paramount, error bars help monitor variability and identify potential sources of error. By analyzing error bars over time, companies can pinpoint areas for improvement and implement targeted interventions to enhance product quality and efficiency. Furthermore, error bars play a vital role in risk assessment and decision-making. In finance and investment, for instance, error bars provide insights into the volatility and uncertainty surrounding asset prices. Investors can assess the potential risks and rewards associated with different investment strategies by examining the width and distribution of error bars, thereby making more informed decisions to mitigate financial losses. In the realm of public health and epidemiology, error bars help quantify the uncertainty surrounding disease prevalence and incidence rates. Epidemiologists use error bars to estimate confidence intervals for key metrics such as infection rates and mortality rates, enabling policymakers to develop effective strategies for disease prevention and control. Beyond their traditional applications, error bars are also increasingly being utilized in data journalism and visual storytelling. Journalists and storytellers use error bars to convey the uncertainty and complexity of real-world phenomena, thereby fostering a more nuanced understanding among their audiences. In conclusion, error bars are versatile tools with diverse applications across various fields, from scientific research to finance, manufacturing, public health, and journalism. By incorporating error bars into data visualizations, analysts and researchers can enhance the transparency, reliability, and interpretability of their findings, ultimately leading to more informed decision-making and better outcomes. A beginner's guide to error bars with Matplotlib's PyPlot. In the world of data visualization, conveying the uncertainty and variability in data is essential for making informed decisions and drawing reliable conclusions. Matplotlib, a popular Python library for creating static, animated, and interactive visualizations, offers a convenient function called error bar within its PyPlot module. This function allows users to easily incorporate error bars into their plots, providing a clear representation of data uncertainty. Let's delve into a beginner-friendly introduction to error bar and explore how it can be used effectively. PyPlot is a powerful module that provides a MATLAB-like interface for creating plots and visualizations in Python. It offers a wide range of functions for generating line plots, bar charts, histograms, scatter plots, and more. Error bar function is one such function within PyPlot specifically designed for incorporating error bars into plots. Using error bar function, the error bar function in Matplotlib's PyPlot module allows users to create line plots or scatter plots with error bars. Its syntax is straightforward. Let's break down the parameters of the matplotlib.pyplot.errorbar function. X. Array-like data representing the x coordinates of the data points. Y. Array-like data representing the y coordinates of the data points. Yeah, array-like data representing the error or uncertainty associated with each data point along the y-axis. If set to none, default, error bars along the y-axis will not be displayed. Z. Array-like data representing the error or uncertainty associated with each data point along the x-axis. If set to none, default, error bars along the x-axis will not be displayed. FMT, string specifying the marker style for data points and optional line style. For example, O represents circles, S represents squares, and represents a solid line. This parameter is optional and defaults to an empty string. Color of the error bars. This parameter accepts a string representing a color name A, G, red, blue, or a tuple representing an RGB color A, G, 0, 1, 0, 2, 0, 5. If set to none, default, the error bars will inherit the color of the data points. Align width of the error bar lines. This parameter accepts a numeric value representing the line width in points. Cap size, length of the error bar caps in points. If set to none, default, the cap size will be determined automatically based on the size of the markers. Barsabov, Boolean value indicating whether the error bars should be plotted above the data points, true, or below them, false. Defaults to false. Lowlimbs, uplimbs, xlowlimbs, zooplimbs, Boolean values indicating whether the data points have lower, upper limits or are specifically marked as such along the y-axis, lowlimbs, uplimbs, or x-axis, xlowlimbs, zooplimbs. These parameters are optional and default to false. Error every, integer specifying the data point interval at which to plot error bars. For example, setting error every equals 2 will plot error bars for every other data point. This parameter is optional and defaults to 1. Cap thickness of the error bar caps in points. This parameter accepts a numeric value representing the line width in points. The asterisk args and asterisk quargs allow passing additional arguments and keyword arguments that are then passed to the underlying plot functions. Let's create a stunning example using Matplotlib. PyPlot. Error bar to visualize the sales performance of a fictional company over several quarters, including error bars to represent the uncertainty in the sales figures. We'll use randomly generated data for demonstration purposes. Import matplotlib.pyplot is plt. Import numpy is np. Generating sample data for quarters x, sales, y, and error. Quarters equals np.array 1, 2, 3, 4. Sales equals np.array 100, 120, 110, 130. Error equals np.array 8, 10, 9, 11, hash assuming plus or minus 8 to 11 units of uncertainty in sales. Plotting the data with error bars. plt.errorbar quarters, sales, year equals error, fmt equals, o, color equals, blue, equaler equals, red, cap size equals 5. Customizing the plot. plt.xlabel quarter. plt.elabel sales in units. plt.title sales performance with error bars. plt.grid true. Displaying the plot. plt.show. We import the necessary libraries. Matplotlib.pyplot is plt for plotting and numpy is np for generating sample data. We generate sample data for quarters, x-axis, sales, y-axis, and error, uncertainty in sales figures. In this example, we have 4 quarters and corresponding sales figures along with the uncertainties, error. We use the plt.errorbar function to plot the data points along with error bars. We pass the quarters as x, sales is y, and error is year, since we are representing uncertainty in sales figures. Additionally, we specify the marker style fmt equals O for circles, color of data points, color equals blue, color of error bars, equaler equals red, and cap size of error bars, cap size equals 5. We customize the plot by adding labels to the axes, plt.xlabel, and plt.ylabel, giving a title to the plot plt.title, and enabling grid lines plt.grid true. Finally, we display the plot using plt.show. This stunning example visualizes the sales performance of the company over different quarters, highlighting the uncertainty associated with each sales figure through error bars. The vibrant colors and clear presentation make it easy for viewer to interpret the data and understand the variability in sales performance. Conclusion on the importance of error bars in visualization. Error bars are crucial components of data visualization, providing insights into the reliability and precision of data. They promote transparency and honesty by acknowledging uncertainty in measurements. Error bars aid in decision-making by helping viewer assess the reliability of data and draw accurate conclusions. They enhance the interpretability of visualizations and facilitate comparisons between different datasets. Conclusion on the imperative of error bars. Error bars are indispensable tools for conveying uncertainty in data analysis. They serve as guardians of truth, offering insights into the variability and precision of data points. Error bars facilitate comparisons between datasets, guiding researchers towards robust conclusions. Their inclusion fosters humility and transparency, promoting a culture of scientific integrity. Conclusion on applications of error bars. Error bars have diverse applications across various fields, including scientific research, quality control, finance, and public health. They provide insights into the precision and reliability of experimental results. Error bars aid in risk assessment, decision-making, and data journalism. Mastering error bars is essential for enhancing the transparency, reliability, and interpretability of data visualizations. Conclusion on Introduction to Error Bar in Matplotlib's PyPlot. Matplotlib's Error Bar function is a valuable tool for incorporating error bars into data visualizations. It allows users to plot data points along with error bars representing uncertainty. Error Bar offers various customization options for marker style, color, and error bar properties. Understanding and mastering Error Bar is essential for creating accurate and informative visualizations in Python. In summary, error bars play a vital role in data analysis and visualization, promoting transparency, reliability, and informed decision-making. Whether in scientific research, business analytics, or journalism, mastering error bars is essential for conveying uncertainty and drawing accurate conclusions from data.